بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. Let us continue some exercises about section 8.2 area of surface of revolution. So here in this question, find the exact area of the surface obtained by rotating the curve about the x-axis. So this is the most important thing for us. When he says rotate about the x-axis, then the formula is 2 pi y ds. And ds is the arc length, and it could be with respect to x and with respect to y. Here in the question, he said x from 0 to 2, so I will work with respect to x. So ds in this case would be 1 plus dy by dx to the power 2. And in this case, the function has to be solved for y. So y is a function of x, which is the case. So y prime is 3x squared, and 1 plus y prime square would be 1 plus 9x to the power 4. So s would be equal to integral from 0 to 2 pi. Now the integral is with respect to x, so and y equals x cube. So I replace y here by x cube and square root of 1 plus y prime square, which is 1 plus 9x to the power 4 dx. And now if I take u equals 1 plus 9x to the power 4, then du is 4 times 9, 36x to the power 3. And I already have x to the power 3 outside. So substitution here, usual substitution works. Let me change the values of x. When x is 0, I replace I replace x by 0 here, so u would be 1 plus 9 times 0, which is 1 plus 0, so u is 1 plus 0. And if x is 2, then 2 to the power 4 is 16, and multiplying by 9, adding to 1, so u would be 145. So now s would be integral from 1 to 145, and I need 36x cube. I have 2, so I will multiply by 18 and divide by 18 outside. So 18 times 2, 36x cube dx would be du, and there is a pi, and I can take the pi outside. Okay, so pi over 18, and square root of 1 plus 9x to the power 4 is just u. So I have pi over 18, u to the power half, add plus 1, so 3 over 2 times 2 over 3 from 1 to 145. So the answer would be 2 over 18, 1 over 9, 3 times 9 is 27, so it's pi over 27. 145 to the power 1.5 minus 1 to the power 1.5 is just 1. So that's the answer. If you need to approximate, you can give 2 or 3 or 4 decimals. Okay, another question. Again, we need to find the surface area. And still here, the rotation is about the x-axis. So in all of these questions, the rotation is about x-axis. So s is integral from 3 to 5 to pi y ds. And ds, I will write it in terms of x here. So I will have 1 plus dy by dx square dx. And here y has to be a function of x, which is the case. So y prime is 1 over 2 times square root of 5 minus x times the derivative of 5 minus x, which is -1, and y prime square is 1 over 4 times 5 minus x. Now 1 plus y prime square would be 1 plus 1 over 4 times 5 minus x. Adding these two fractions, we have 4 times 5 minus x. So let me multiply because I need to simplify in the numerator. So 4 times 5 is 20 minus 4x plus 1. So the answer is 21 minus 4x over 4 times 5 minus x. Now the surface area would be integral from 3 to 5 2 pi. Y should be written as a function of x because I have the x. And now square root of 1 plus y prime square. So distributing the square root, I will have square root of 21 minus 4x over square root of 4, which is 2, times square root of 5 minus x dx. So I will have square integral from 3 to 5 of 21 minus 4x dx. Now this is a linear function, so I can just write it 21 minus 4x to the power half, and then add 1, and so multiply by 2 over 3, and I need to divide also by 1 over -4, the derivative of 21 minus 4x. And I should evaluate from 3 to 5. So I will write it. Now 2 over 4 is half. So I have -pi over 6. Okay. And then I have 21 minus 4 times 5. So it's 1 minus 21 minus 12. That's 9. And then I raise 9 to the power 1.5. It's 27. So that's good. So minus 27. So the answer would be -26. So it would be positive, and 26 over 6 is 13 over 3. So the answer is 13 pi over 3. Here, still the rotation is about the x-axis. So 2 pi y ds. And I have the limits of x here. So I will write the ds with respect to x. So 1 plus y prime square, or dy by dx square. And I need y to be written as a function of x. So y is square root of x plus 1. And it could be positive or negative here. And y prime would be 1 over 2 square root of x plus 1. And y prime square would be 1 over 4 times x plus 1. So 1 plus y prime square would be 1 plus 1 over 4 times x plus 1. And this would be 4x plus 1. I will expand. So 4x plus 4 plus 1 over 4x plus 1. So 4x plus 5 over 4 times x plus 1. So the surface area would be from 0 to 3 to pi. And now y, I have to write it as a function of x. So it's square root of x plus 1. times the square root of this 1 plus y prime square, which is square root of 4x plus 5 over square root of 4 is 2 times the square root of x plus 1. Cancel, cancel. And this is exactly similar to uh, this exercise here. The previous exercise, you can just write it linear function to the power half and add plus 1 and divide, and don't forget to divide by 4 the derivative of 4x plus 5. So I leave this for you to continue, exactly similar to the previous one. Here, S again with respect rotation with respect to x-axis. So 2 pi y, 1 plus y prime square dx, because the limits are given with respect to x, and y prime is written as function of y, so that's good. So let us find y prime. It's the square root, so again the derivative of the square root is 1 over 2 square root of 1 plus ex times the square root of 1 plus ex, which is ex, e to the power x. And then y prime square would be e to the power x square, e to the power x all square, or it would be e to the power 2x over 4 times 1 plus e to the power x. And 1 plus y prime square would be 1 plus e to the power 2x over 4 times 1 plus ex. And this would be equal to 4 times 1 plus ex, and let me expand 4 plus 4ex plus e2x. And now if you look to these three terms, I have e to x, which is ex raised to the power 2, and I have 4 times ex, and I have 4. Actually, these three terms can be written as a perfect square. Okay, so how to write it as a perfect square? You take the root of ex squared, which is ex, the sign of the second term, and the root of the last term, and you raise it to the power 2. Because the first term has a root, the last term has a root, and if you multiply the root of the first term times the root of the second term times 2, you get the number or the term in the middle. So I can change these three terms into a perfect square like this. So now S would be integral from 0 to 1. Y, I should write it in terms of x as a function of x, and square root of 1 plus y prime would be the square root of this fraction. So square root of the numerator, we will cancel, square root will cancel the 2, the square, and below square root of 4 is 2, and I will have square root of 1 plus ex. Cancel, cancel, and now the integral is easy. Integral of ex plus 2. That's just e to the power x plus 2x from 0 to 1. So e to the power 1 plus 2 minus e to the power 0, which is 1 plus 0, so that's it. So the answer is e plus 1. 2 minus 1 is 1 times pi. That's the exact answer. Another question, and still the rotation is about the x-axis. So 2 pi y ds But now the limits of y are given. So I will write ds as 1 plus dx by dy or x prime times or dy. So the integral would be with respect to y. And here x to be written has to be a function of y, and that's the case. So I can find x prime immediately. X prime would be 3 over 2 times 1 over 3 times y squared plus 2 to the power of 3 over 2 minus 1, which is half, times derivative of y squared plus 2, which is 2y. 2 cancels with 2, 3 cancels with 3. So x prime is in fact y times the square root of y squared plus 2. Now 1 plus x prime square would be 1 plus. When I square this, I will get y squared times y squared plus 2. So this is 1 plus y to the power 4 plus 2y squared. And this is y to the power 4 plus 2y squared plus 1. If you notice, the first term has a root, and the third term has a root, and the sign of the second term is positive. So these three terms could be written as a perfect square like this. 1 times y squared times 2 will give you 2y squared. So this would be the integral from 1 to 2 pi y. Now there is no need to write y as a function of x because the integral is with respect to y. So I keep it as y. And then square root of 1 plus x prime square would be square root of this, and square root cancels the square, and I'll have y squared plus 1. And now this is an easy integral because y times y squared is y cubed plus y dy. Just continue, please, and find the answer. The integral, again, with respect to the x-axis. So still the formula is integral 2 pi y, and y here is from 1 to 2. So I will write ds with respect to y. So I will write here 1 plus x prime or dx by dy square. That's the formula, and x should be written as a function of y. It is. So x prime is 4y, and 1 plus x prime square would be 1 plus 16y square. So the integral would be from 1 to 2 pi y as it is, and square root of 1 plus 16y square. And this integral is easy. Just take u as 1 plus 16y square. The derivative is outside, and you can continue easily. Now, the curve is rotated about the y-axis. So the formula would be integral 2 pi x ds. And ds, I can write it in terms of x or y. X here is given from 0 to 12. So I will write it in terms of x. And I'll have 1 plus dy by dx or y prime square. And I need y to be a function of x here, which is the case. So y prime would be 3 over 2 times 1 over 3 x to the power 3 over 2 minus 1. And then 1 plus y prime square would be 1 plus, and y prime square is 1 over 4, and x to the power half. When you square it, you get x, so it has x over 4. I can add these two fractions, so I have 4 here and 4 plus x here. So the integral is from 0 to 12. 2 pi x is okay because the integral is with respect to x. And I have here square root of this one. Distribute the square root, so I will have square root of 4 plus x over square root of 4, which is 2, And now I can solve this also by substitution. If I take u equals square root of, not square root, what is inside the square root, 4 plus x. So du would be dx, and this would be integral pi, and x is from here, x is u minus 4 times square root of 4 plus x, which I called u du. Just change the values of x to u values and continue easily, because here you have u times square root of u, so this is u to the power 3 over 2 minus 4u to the power half. So evaluate the integral, put the values of u. If x is 0, u is 4. If x is 12, u is 16, and continue and find the answer. Integral rotation with respect to y-axis. So the surface area is given by the formula integral 2 pi x ds. Well, here he gave me y values, so I will choose the integral with respect to y, and then I must have dx by dy to the power 2, and y is from 0 to a over 2. Now here I need x to be a function of y, which is the case. So x prime or dx by dy is 1 over 2 times square root of a square minus y square times the derivative. Derivative of a square is 0, it's a constant, minus 2y. So 1 plus x prime square would be 1 plus y square, and the negative sign will disappear. Negative to the power 2 is 1. And here I will have a square minus y square. So I have a square minus y square when we add, and I have a square minus y square plus y square. So the integral would be from 0 to a over 2, 2 pi. Now x, I have to write it as a function of y, because the integral is with respect to y. So x is square root of a square minus y square. And now times square root of 1 plus x prime square. So square root of a square is a, and square root of a square minus y square dy. These two cancels, and 2 pi a is a constant. So times a over 2 minus 0. So it is in fact 2 cancels with 2, and I have a times a, which is a square times pi, and that would be the answer. Again here, the rotation is about the y-axis, so 2 pi x ds. But here the values of x are given, the limits. So I will write ds in terms of dx. So I will have 1 plus dy by dx square. And here I need y to be written as a function of x, which is the case. So y prime would be derivative of x square is 2x over 4 minus half. Derivative of ln x is 1 over x. So it is x over 2 minus 1 over 2x. And now y prime square is x over 2 minus 1 over 2x square, which is x square over 4 minus 2 times the first term times the second term plus the square of the second term. X cancels with x and 2 cancels with 2, and I have negative half here. So x square over 4 minus half plus 1 over 4 x square is just x over 2 minus 1 over 2x to the power 2. And this is y prime square. Now what would be y1 plus y prime square? I add 1 to these three terms, and when I add 1, it would be added with the negative half. 1 minus half would be positive half. Then these three terms are the same three terms except with a negative sign, change it to positive. So I have the same perfect square, changing the negative sign to positive. So actually 1 plus y prime square equals to this. We have seen this in section 8.1. So please, if you need more information, go watch section 8.1 first. So this would be integral from 1 to 2 pi x, and square root of this of 1 plus y prime square. Square root will cancel the square, and we will have x over 2 plus 1 over 2x dx, and the integral is easy. I can multiply the 2 inside, so I will have pi x times x plus 1 over x, or from 1 to 2 pi x square plus 1. So the integral of x square is x cubed over 3. Integral of 1 is x, and you need to find the numbers, replace x by 2 minus 1, and find the answer. And that's it. I hope you understand now how to find the surface of the surface area.